Now we're going to verify similar circles. So in questions 1 and 2, state the similarity transformations needed to map circle B onto circle A. So this order matters. It's going to impact what we write for our transformations. So if we want to map circle B, which is the red circle, onto circle A, which is the blue circle, we know that these mappings are going to involve two particular transformations. The first is going to be a translation and the second is a dilation, but it's up to you which order you're going to write them in. So if I wanted to first translate circle B over to circle A, we would translate the center point. So we could see that this center would move right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And then it would translate up 1, 2, 3, 4, 5, 6, 7, 8 units. So if you wanted to list your translation first, you would say that first we would translate and then you would give the vector. We would say right 10 and up 8, so both of those numbers would be positive. After we've done that, then the circle would be located with the center here, but it would still have that radius of 3 units. So if I were to draw that in 1, 2, 3, 1, 2, 3, 1, 2, 3, the circle would be right here, which means we would still need to dilate the circle so that it would actually have the same radius as circle A. So our second step would be to dilate about a center. And so we need to say what the center is. So this center is the point 5, 4. By a scale factor of, well, remember your scale factor is new over old. So the new circle has a radius of 1, 2, 3, 4, 5 units, and the old circle had 1, 2, 3 for its radius. So new over old would be 5/3. So you could write it this way. However, that's not the only answer. It's just one of the answers. So if you would have preferred, you could have first said to dilate the circle. So you would dilate, but instead of it being about this center, you would keep it about this center over here. So dilate about the center B, which has the coordinates -5, -4, by that same scale factor of 5/3. And what that's going to do is it's going to keep the center here, but now you're going to have the circle that has the radius of 5. So you have the circle that's now the same size as circle A. Wow, that is a rough circle. But what you can do then is translate that now. So then your second step would be to translate, but you're still going to translate by the same amount. You're going to go right 10 and up 8. So depending on the order, the only thing that changes is what the center is of your dilation. So here we dilated about the center up here, and here we dilated about the center here. So it's just a matter of what you're going to do first. So it's truly up to you. I'm not going to write both answers for all of these. I'm just going to write one of them, but just know that it's up to you how you want to do it. You just have to adjust the center of your dilation. So to go from point B to point A here, I can see that the center would move right 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 3. So your first option, you could say to translate by your vector right 9 and down 3. So +9 and -3. And then after you've moved it, then you want to actually dilate it. So you're going to dilate about the center. Since you've already moved it over here, the center is now here at 5, -2 by a scale factor of, well, new over old. So new has a radius of 3, over old has a radius of 1, 2, 3, 4, 5, 6. So 3 over 6, which is a scale factor of 1/2. Again, you could flip-flop these, and you could say dilate first, except you would say dilate about the center -4, 1 by a scale factor of 1/2, and then you would translate 9, -3. The next two problems are the same type of problems. It's just instead of given a graph, you're given a description. So number 3 says, show that circle D with center 2, 3 and radius 4 is similar to circle E with center -2, -4 and radius 7. So for instance, maybe here, I want to talk about dilating first. So first, I might dilate. And it's up to you. Do we want to go from circle D to circle E or circle E to circle D? It didn't specify. So I'm going to go ahead and just write over here that I'm going to go from D to E, just so we can keep this straight. So if I want to go from circle D to circle E, I'm going to dilate about this circle's center. So about center 2, 3 by a scale factor of new over old. So new is going to be 7 if I'm going from D to E. So 7 over the old over 4. So 7/4. And then we can translate, and we have to pay attention to where our centers are. So if we had a center at 2, 3, so here was our center for circle D, and then for circle E, it was -2, -4 down here. You have to think about first you move left, and you're going to move left 4 units. So translate -4, and then you're going down 3 units, and then another 4 units, so down 7 units. So -4, -7. Again, you could flip-flop these, it's up to you. Show that circle M with center 0, 4 and radius 8 is similar to circle P with center 4, 0 and radius 2. So again, pick your the way that you're going to actually transform these. So if I go from circle M to circle P, let's say first maybe I want to do the translation this time. So I'm going to translate to go from the center 0, 4 to 4, 0. 0 to 4 means I'm going right 4 units. But if I was 4 units above the x-axis and now I'm on the x-axis, that means I'm going down 4 units. So there's our vector. So now my center is already sitting on top of circle P. So when I do this dilation, the center of circle P is now my center of dilation. So dilate, whoops, we want to say dilate, not dilation. So we're going to dilate about the center where P is, which is 4, 0, by a scale factor of, well, new over old. If P is the second one, so P has a radius of 2, over old, which is a radius of 8, so 2 over 8, that's going to be a dilation of 1/4.